All right, so this video is going to help you do your special right triangles homework sheet. So if you recall, there's 3 major steps in order to do this. So the assumption is that you write a trig function. So let's say you have sine of 30 equals x over 7. So the assumption is you do have something. So whenever you get that set up, your first step is to substitute in the values that you have for that trig function. So sine of 30 is 1/2, so you just plug that in. Then after you substitute, you will cross multiply. And then after you cross multiply, you're just going to solve for your variable. Okay, so looking at the first one, we have, let me change my color. We have this little triangle, and we have B, A, 2 square root of 2, a 90, and a 45-degree angle. And we want to find out what is A and B. So for me, I prefer to focus on one angle. That way I can just label my sides and not have to think anything else of it after that. So looking at this, if I'm referring back to that 45-degree angle that I just highlighted, I know A is my hypotenuse, B is my adjacent, and 2 square root 2 is my opposite. So if I want to find A first, remember we have SOHCAHTOA. So if I want A first, I'm going to have something that has an H because I need the hypotenuse. So because the only known thing I have is an opposite, we're going to use sine. So we'll have sine 45 equals opposite over hypotenuse. And then you substitute. So we're going to substitute in sine 45 is square root 2 over 2. And remember, you can just check that chart that we made in class. So then you have that. And then you'll cross multiply and solve. So we'll do this first one together all the way. So when we cross multiply, we have A times the square root of 2 equals 2 times 2 is 4 square root of 2. And then I divide by square root 2. Boop, boop. And then A equals 4. Oops, 4. Okay, so then if I want to find B, I'm going to have some options. Because now that I see that my A is a whole number, I could possibly use cosine if I wanted to, because I have an adjacent and a hypotenuse value that's just a whole number. If your value that you find is not a whole number, then I would recommend not using it again, just so that you don't have any rounding issues or anything funky happening. So if I want to find B, I have 2 options, so I'll do both. Looking at that 45-degree angle, I could do cosine of 45 like I was saying, and cosine of 45 would be adjacent over hypotenuse. So my adjacent is B, and then my hypotenuse is A, but remember we found that value to be 4. So A is a value, or that 4 is the value I found for A. So just keep that in mind when you're choosing which trig function to use. So then we're substituting in cosine of 45 is square root 2 over 2. And that equals B over 4. So when we cross multiply, we get 2B equals 4 square root of 2. And then we divide by 2. And 4 divided by 2 is 2. So we have 2 square root of 2. Now, let's say you did not want to use cosine because you didn't want to use a value that you'd come up with. That's totally fine. You can also do tangent of 45, because tangent of 45 would be your opposite, 2 square root 2, over your adjacent, B. You're still going to be substituting in values. So tangent of 45 is 1. Oops. So 1 equals 2 square root 2 over B. And if you want, you can write this as 1 over 1. But what ends up happening when you cross multiply is you just get that B equals 2 square root of 2. So you notice it doesn't matter which way you do it. You will get the same thing regardless. Just kind of depends on what you prefer. Okay, so the next ones, I'm not actually going to solve the whole thing. I'm sorry. You'll have to use your brain. But for number 2, we have a right triangle, and I'm just going to label it fast because you guys should have it in front of you, and we know 45. So because I know that 45 degrees, if I am focusing just on that angle alone, then I would have x as my opposite, y as my adjacent, and 4 as my hypotenuse because my right angle is in there. Okay, so if I want to find x, I see that I would need opposite, and because the only other value I have is hypotenuse, using SOHCAHTOA, I know I need sine. So sine of 45 equals opposite over hypotenuse. Then we substitute in the value. Sine of 45 is the square root 2 over 2, and that equals x over 4. So you'll just have to cross multiply and simplify to solve that one. So then if I wanted to find y, then you could just do cosine of 45, because cosine of 45 is adjacent, which is y, over hypotenuse, which is 4. And then cosine of 45 is square root 2 over 2. Ooh. And then equals y over 4. So then you'll cross multiply and solve again, just like the others. For number 3, Number 3 may be a doozy for some of you just because you're going to have a fraction in a fraction. And it's not the end of the world. It just looks kind of funky, and sometimes it freaks people out. So don't freak out. So if I wanted to find x, and they labeled this angle up here. So again, I generally just base it off of that angle. That way it's really easy for me to find. So looking at that 45-degree angle, we have our hypotenuse, our opposite, and our adjacent. So because I want to find x first, I see that I have adjacent and hypotenuse. So because I have adjacent and hypotenuse, I'm going to use cosine. So cosine of 45 equals 3 square root 2 over 2, our adjacent, over our hypotenuse. And I find when I have complex fractions like this, I generally just make a really big dramatic line for that. So then cosine of 45 is the square root 2 over 2, and that's going to equal 3 square root 2 over 2 over x. So when you cross multiply, just to give you a hint on this, because I know you guys can do x times square root 2, when you do 3 square root 2 over 2 times 2, remember that's times 2 over 1, and you're just going to multiply straight across and simplify. So just be careful of that. Don't be afraid to go off to the side and finish that up, okay? But then to find y, because remember, I'm not solving all these, I'm sorry. But to find y, because that's our opposite and adjacent, I would do tangent of 45 equals opposite over adjacent. Okay. Now, I will say there are multiple ways that you can do these. So just remember that sometimes your work may be slightly different than mine based on which trig functions you use and which angle you're based it off of. But with tangent 45, you're still going to substitute in the values. So tangent of 45 is 1 over 1. So then you have y equals 3 square root 2 over 2. And then you'll cross multiply. Okay. So moving on, number 4. Because I'm trying to make this a fast video, but we'll see how we actually do. We have 45 degrees, x, y, and 3 square root of 2. So if I am trying to set this up, I see hypotenuse, opposite, and adjacent. So let's start with x. If I'm basing it off of this 45-degree angle, I have adjacent and hypotenuse. So I would use cosine of 45 equals adjacent over hypotenuse. In order to find y, I need my opposite, and I would probably refer back to my adjacent again. So then that would be tangent of 45 equals opposite y over adjacent 3 square root of 2. Now, if you ended up, if finding that x was just a whole number, then you could also use cosine again of 45. Or not cosine, sine to find the y, and then just plug in the value that you find for x for that. Okay. And remember, cosine of 45 is square root 2 over 2. And it equals all that lovely stuff. And tangent of 45 is 1 over 1. And all that fancy stuff. Okay. Oops. All right. For number 5, we got another 45, 45, 90. And they give us this angle up here is a 45. So if I had to find this, I would do, let me change. I should probably just make it so that I can just tap on this one. That would be the smart thing. But we have our hypotenuse, our opposite, and our adjacent. So if I wanted to find x, I would do sine of 45 equals opposite over hypotenuse. And then if I wanted to find y, I would just do cosine of 45 equals adjacent over hypotenuse. And then you'll plug in those values. So remember, this is square root 2 over 2. And cosine is square root 2 over 2 as well. And then you'll cross multiply and solve. I'm going to see if I can squish another on here. For number 6, this triangle is oriented kind of funky, but it's still a right triangle. It's still 45 degrees. Oops. So if I'm basing it off of the angle that they labeled, this is my hypotenuse, my x is my opposite, and my y is my adjacent. So then, if I'm trying to find x and y, you're going to do basically the same thing we just did. Sine of 45 equals x over 2 square root 6, and cosine of 45 equals y over 2 square root of 6. Notice, I know I did it quick, but this was my opposite side, and this is my adjacent side. So then we're just putting it over the hypotenuse. And then plug in those values for sine 45 and cosine 45, just like we did on number 5. For 7, looking at it, now it's a 30, 60, 90. So this is our 60. And we have y, x, and 16. Oops, 16. So for this one, we have our hypotenuse still, our adjacent, and our opposite. So looking at what we have, because this is a 30, 60, 90, we're going to have to actually be a little bit more careful about which trig function we use, because you can kind of get away with it a little bit with 45, 45, 90s. So with this one, if I want to find x first, I'm going to use sine of 45. See, I'm so used to it. Sine of 60 degrees equals opposite x over hypotenuse 16. And then sine of 60, just to remind you, is the square root of 3 over 2. And then if I want y, I'm just going to do the cosine of 60 equals y over 16. And then cosine of 60 is 1/2. So then you'll just cross multiply and solve that. For number 8, we have these side lengths. So because of that 30 degrees, I'm going to base everything off of that. So I have my hypotenuse, my adjacent, and my opposite. So then if I want to find, let's say u first, I would use sine of 30 equals opposite 2 over hypotenuse, which is u. And then sine of 30 is 1/2. So then you'll just solve that one. To find v, I would need adjacent and opposite. So I would do tangent of 30 equals opposite 2 over adjacent v. And then tangent of 30 is square root 3 over 3. Okay. So then you'll just cross multiply and solve like you were before. Right? Running to the back, again, we're going to try and run through this real quick. Number 9, with that triangle, because we're doing 60, to find the u first, that's our hypotenuse. So I would use, not sine, I would use cosine of 60. Oh my goodness, maybe I should draw the pictures. I'm fired. Not really, don't worry. 60 degrees. Okay, so that's a U. What is my problem? So because I have this is hypotenuse, adjacent, and opposite. So because I have this, I have my adjacent and my hypotenuse, so that's going to be cosine of 60 equals adjacent 8 over hypotenuse U. And then to find V, I would probably want to use tangent. So tangent of 60 equals opposite V over adjacent 8. Okay, and then cosine of 60, let's see, 60, I'm using my hand again to remind myself. Cosine of 60 is 1/2. And then tangent of 60 would be just the square root of 3 over 1. Okay. So then for number 10, this is another oddly shaped one. Y, X, and a 60. So to do number 10, if I wanted to find X, which is my opposite, I would want to use sine. So I'd have sine of 60 equals opposite over hypotenuse. And then from there, you can go ahead, plug in the value for sine of 60 and then cross multiply. Now you got to look some of it up on your own. To find A, or Y, I'm sorry, to find Y, that's going to be adjacent over hypotenuse. So then we'll just do cosine of 60 equals adjacent Y over hypotenuse 8 square root of 5. Okay. I want to see, there shouldn't be any other crazy questions on here, but I'll do a few more just in case. So we have 11. I would use, let's see, because I have that 60 and I want my hypotenuse, I would need to do sine of 60 equals opposite 5 square root 3 over hypotenuse, which is X. And then to find Y, I would just do tangent of 60 equals opposite over adjacent. Okay. And for number 12, and again, you can plug these values in and get it set up. Ideally, you're able to, by this point, hopefully you're able to get them on your own. Maybe just pause it every so often, see if you're getting them right. But for 12, because we need that X and the Y, I would use sine again. So sine of 60 equals opposite X over adjacent 10. Okay, and then to find Y, I would just use cosine of 60 equals adjacent over hypotenuse 10. Okay, and again, you're plugging in the values on your own. You can handle it, I promise. So for number 13, because we're doing 45s, it doesn't really matter if you use sine or cosine because it's the leg lengths, but sine of 45 would give me opposite U over 8 square root of 2. And then you would also have cosine of 45 equals V over 8 square root of 2. Okay. For number 14, I'm just trying to get these set up for you because hopefully by now you're able to get most of it. So for 14, to find X, I would use cosine of 30 equals adjacent 12 over hypotenuse X. And then to find Y, I would do tangent of 30. Tangent 30 equals opposite over adjacent. Okay. Oops. That's fine. So then for 15, we have 60 degrees, and the A and the B are our leg lengths. So if I wanted to find A, that would be opposite. So I'm going to use opposite over hypotenuse, which is sine of 60 equals opposite A over hypotenuse 3. And then if I wanted B, I would just have cosine of 60 equals adjacent B over hypotenuse of 3. For number 16, we're looking at the 30 degrees, and A is actually our hypotenuse this time. So I would have to do cosine of 30 equals adjacent, which is 11 over square root 3, or sorry, 11 times square root 3, over our hypotenuse A. And then to find B, I would use tangent. So tangent, because I have an opposite and an adjacent of 30 degrees, is opposite B over adjacent 11 square root 3. For number, let's see if I can find a different color now. For number 17, we have the 60 degrees, and the A and B are our leg lengths. So if I wanted to find A, I would need opposite over hypotenuse, which is sine. So sine of 60 equals opposite A over hypotenuse, 2 square root 2. And then if I wanted to find B, I would need my adjacent over hypotenuse. So that would be cosine of 60. Let's see if it'll actually equals adjacent B over 2 square root 2. And then last but not least, number 18. We have the 45 degrees, and M and N are our leg lengths. So sine of 45, my opposite is M over 7. And then cosine of 45, and it is N over 7. So hopefully this video helped you, and let me know if you have any questions or clarifications.